Question number 21 on our test 1 review. You're given the function f of x equals the opposite of 3x plus 4, and you're asked to sketch it to show basically what the solution set would look like. Since it's made up of infinitely many ordered pairs, you have to show that graphically. Let's go to my paper. There are two ways that I'm going to show you how to do this problem. And I want you to eventually, I want you to end up picking the way that you're most comfortable with, but I really think you should know both. Now, first of all, another name for f of x is y. So this equation is really y equals the opposite of 3x plus 4. And we eventually want to draw the solution set, which is the set of all ordered pairs that make this equation true, on a graph paper. Now, one way to do this is to just sort of create your own list of ordered pairs that satisfy this equation, kind of like what we did before with the models. You can make up values to put in for x and then use the formula to see what you would get out for y. So putting in 0 is a pretty easy thing. When you put in 0, negative 3 times 0, 0, 0 plus 4 is 4. If I put in a 1, negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. So when I put in a 1, I happen to get out a 1. If I put in, let's say, a negative 1, negative 3 times negative 1 is 3. 3 plus 4 is 7. And of course, I could continue doing this. I think what you're going to realize here is when I plot these points, I have the ordered pair 0, 4, which is approximately there. You may want to do this at home on graph paper because it's a little bit more accurate. I have the ordered pair 1, 1, which is approximately there. And I have the ordered pair negative 1, 7, which is approximately there. And I think what you'll notice is these points are collinear, and what that means is they lie on the same line. So the graph of this equation is a straight line. That does not surprise us because notice that the original function you started with was linear, right? Degree 1, it fits the form of a linear function, so we expect a line. Plotting points to get the equation, to get the graph of the equation, is perfectly acceptable. And the truth is you really only needed 2 points to connect. Once you realized it was a linear function, 2 ordered pairs on that line would have been enough to connect the whole graph. What I do want you to realize is this line has infinitely many points on it, and each one of those ordered pairs from the line is a solution of this equation. So that's what you're really doing here. You're solving this equation. Now, let me show you another approach that some of you may like better than plotting points. I personally do. All right, some of you have been taught, or you remember from the past, something about slope and intercept. The form y equals mx plus b is called the slope-intercept form of a line. The number, when y is by itself, the number in front of the x represents the slope of the line. So in this case, the slope of the line is negative 3, which we can really write as negative 3 over a positive 1. The y-intercept of the line, which is this constant, the b value, is 4. Now, using these 2 pieces of data from our linear function, we can draw the graph without having to go through all this point plotting stuff. All right? I always teach my students, think of B as begin here. All right? Don't start with the slope. Slope is not a location. Slope is the rate at which you're climbing. It's sort of directions on how you're walking up the line. We have to have a place to begin. B is the y-intercept of the line where the graph touches the y-axis. So we begin our line by locating the y-intercept, which in this case is 4. So we go to graph paper, and on the y-axis we find the number 4, and we put a dot there. That is my y-intercept. That is where I begin this process. All right? So I begin on the y-axis at 4. Now I use the slope. I always like to write slope as a fraction. -3 is on the top, +1 is on the bottom. When you see a whole number, always put it over 1. -3 on the top, +1 on the bottom means that anytime I'm walking on this line, what I'm going to do is I'm going to go down 3 blocks and 1 to the right. Down 3 blocks and 1 to the right. So, if I start here at the y-intercept and I go down 3 blocks, 1, 2, 3 down because it's negative, and then 1 to the right because the bottom number is positive, I get here. Walk with me. Start with the y-intercept, go down 3 blocks and over 1. Play my connect the dots game, and I have the graph of my line. And of course it's the same graph as the one that I got up here. Alright? It's identically the same. This first graph was obtained by plotting points. This second graph was obtained by using the slope-intercept form of a line, where you graph the line starting with the y-intercept and then going to the slope. Me personally, I like this second method better. And I really think you should know both of them, but I think you should start learning to depend more on that second method.